Hey everyone, today we are going to solve LeetCode problem number 1235, maximum profit in job scheduling. In this problem, we are given n jobs and we are given the start time, end time, and the profit associated to that job. These three values of the jobs are given to us, and what we have to return is we have to choose among these n jobs, we have to choose a subset, let's say m jobs, such that the profit is overall profit is maximized and no two jobs are overlapping. Okay, let's take, if we look at this example here, the start time, four end times, and four profits are given to us. For the first job, this is the start time, this is the end time. It means the first job will start at 1 and at 3. This is the first job, and the profit it will give to us as 50 rupees or 50 unit. And for the second job, it will start at 2, start at 4, from 2 to 4. This is the second job, and the profit we will get from second job is 10. And this is the third job, from 3 to 5, 3 to 5. And the fourth job is 3 to 6, 3 to 6. And we have to choose as many as job from this set of n jobs such that the profit is maximized and no chosen jobs are overlapping. For a single unit of time t, we can end a job and start a job. That is also fine. So by looking at the diagram, it's clear to us that if we choose the first job and the second job, or sorry, for the first job and the fourth job, first job profit is 50 and the second job, fourth job profit is 70. So overall profit is 120, which is the maximum profit we can get by considering first and the fourth job. So this is what we have to return. So ultimately it's a maximization problem which we generally solve using dynamic programming, or you can also consider that we are given, let's say here we are having 4 jobs and we have to choose a subset of these 4 jobs such that the maximum profit we will have and no two jobs are overlapping. So we have to choose a job accordingly that it is not getting overlapped with any previously chosen jobs. So at every step we are having two possibilities. Either we can skip that job or we can consider that job. Okay, so it is going 0-1 knapsack problem where we generally have 2 raised power n possibilities which we can further optimize by looking at some conditions like or doing the memorization and all. Yeah, so this was the overall problem set given to us, and this is also a very important problem, has been asked in many companies recently. Adobe, Microsoft, Uber, Atlassian, Airbnb, Flipkart, Amazon, and so okay. So it's clear to us that for every job we are going to either consider it or do not consider that. If we are considering those job, so we have to be do that in an order. We cannot randomly just check whether a job has to be considered or not. If we randomly do that, let's say the first job given to us is 3 to 5 with profit 40, and the second job is from 1 to 3. So if it is not in the order, it is going to give us extra complexity to iterate on the whole array and adding another n multiplier to our time complexity. So to overcome that, what we are going to do is we can sort these jobs according to the start time, so that so that on the first job we will consider at in the starting, and the subsequent job we will check the ending time. The ending time of the first job should be less than equal to start time of the next job we are going to consider. In this way we can go iteratively. Okay, let's consider a bigger example where we have 4 jobs and we are given the start time and end time of every job. let's not consider the profit for now. So if we go in a recursive way, following 0 1 knapsack problem that considering or declining every job. In that case, let's say if we have considered the 0th job, we are left with two possibility. On the 0th job, we have two possibility. Either we can skip the 0th job and continue finding our answer. If we schedule the 0th job and then we find our answer. If we skip the 0th job, then we can directly start from first job because first job is not overlapping with anyone. But if we have scheduled the 0th job, our 0th job is ending at 3. It means we can consider a job which is starting from 3 or later. So once we have considered the 0th job, we can only start from second onwards. So now we are starting from second. So if we have skipped the 0th job, we can start from 1. On the 1, it means what we are going to return from the top, the answer of the whole problem, and from the right side, the answer of the this subset, the last two jobs, and from here the answer of last three jobs. So even on the one, we have two options, whether we skip the one job and the schedule the one job. If we schedule the first job is ending at 4. So it means we can start a job which is starting 3 or later. It means we cannot start any job, and I think we have to erase this. There is no call from here. No call if we consider the first job. If we skip the first job, we have two possibility. Either consider the second job or skip the second job as well. On the second job, if we skip the second job, we can easily consider the third job. If we consider the second job is ending at 5. It means we cannot make any further call consideration of any job. So this is going to be the recursive call if we consider or drop every call one by one. But this is we are doing after sorting the array. Otherwise, every time we have to see like what are all the jobs we have considered and which job is the subsequently next job. Okay. Now if you look at the recursion stack, so we first solve the problem 0 1 2 3 with 4 jobs, and then we solve the problem with 2 jobs, which is here, and then we solve the job problem for 1 2 3, which is this. And in this call itself, we are solving the problem 2 to 3. This one is 2 to 3. Here if you see that this 2 to 3 job we are already solving here, but we are not memorizing it anywhere, and after some time we are solving this again. So here you can see that we are having overlapping subproblems. To overcome these overlapping subproblem, we can just memorize our answer, that starting from second job onwards till the next last job, what is the answer? That answer we can store. And in our constraints, we are given that our job's length is 5 into 10 power 4. 50,000 jobs we can have. It means if we are starting from, let's say, kth job, we can store the answer in an array. So for that, we can take a memorization array of length 50,000 plus 1, because we want 50,000 as our index as well. Okay, so here this is our top-down dynamic programming, where ultimately we are finding answer from 0th job to end job by splitting it in some options, like we are skipping the 0 and considering the 0. So if we skip the 0, we are finding answer of 1 2 3, and if we are considering 0, we are finding answer of 2 and 3, and ultimately we are returning the maximum answer. Okay, so what is going to be the formula? Let's say we have 0th job, we are skipping the 0 job. If we skip the 0 job answer is not going to be added in our answer. So we had 0, 1, 2, 3, 4 jobs. So if we are going to skip the 0th job, we need to find answer from 1, 2, 3. Okay, the answer of 1 to 3 jobs. If we schedule the 0th job, we are considering the 0th job. It means we need to check after which index I can schedule my jobs, because from that job the starting point should be greater than equal to the ending point of 0th job. So the profit from 0th job plus profit from the next index, next valid index. So the next valid index here is 2 and 3, because 2 we can schedule safely if we schedule 0. So profit from 0 job and then profit from 2 3 job in combined is the candidate. So these two are our candidate for our answer, and we have to return the maximum value among these two. At every index, what we can do is we can memorize this result against the position. Let's say in this case, this is the result of mem of 0. So for at any recursive call, we can store the result of memorization of k. That's starting from k till end jobs. What is the answer? Okay, now let's try to first code the top-down approach of this problem. Here we have a catch. For the same reason it is mentioned as hard. That, let's say we have 0, 1, 2, 3 jobs. If we are considering the 0, if we are not considering the 0, then it is fine. We can move to the first job. If we are considering 0, it means we have to iterate over this array to see what is the next index. What is the next index from which we have to start again. So for that next index, what is the condition? That the ending time of 0 should be less than equal to starting time of k. For this condition, we are going to iterate here again and again. So we are adding an extra n multiplier to our time complexity. To overcome that, what we can do is, instead of n, we can do it in log of n time. Problem statement here, that we have to find the next index such that the ending time of 0 is less than equal to the starting time of the job. So we can find the next index using binary search. So if we are going to use the binary search, instead of searching it again manually, we are reducing our overall time complexity to solve this problem to n of log n instead of n square, which was recursion with memorization if we doing iterative way to choose our next job position. Okay, so our formula was solution of job from the next position if we are skipping it. If we are not skipping it, consider that profit and profit from the next index, and this next index is going to be calculated using binary search. Okay, now let's code this problem. Let's have a look at the code. Here what we have done is, first of all, we are given a job scheduling method where we are given start time, end time, and profit. So I have consolidated these job in a single unit integer array and added to a list of jobs. Okay, after adding it to the list of job, I have sorted the list based on the start time of every job. So now every job in the jobs list is sorted in as per the start time. Now what I have done is, we don't need that print statement. Now we have our jobs, and the start time array I have used to do the binary search, where we will be figuring out the next index. If once let's say we have picked the 0th job, we will try to find out the index that we have to pick after that job. such that there is no overlapping. So find maximum profit. We are passing jobs, start time, where we have start time in the increasing order and from 0. It means this will figure out the result of our problem starting from the index 0 till the last index. Now maximum profit. Here, this is our base case. If index is equal to n, it means we are left with no jobs that we can consume. It means 0 will be added to our answer. Otherwise, we have two possibilities. Either we consider the job at the index position. If we consider the job at the index position, we have we will make this call: find maximum profit, jobs, start time, and the index plus one. Start time is nothing, just a array of storing all the start time of every job, and then index plus one. If we are not considering the first job, there is nothing to worry about. Start considering from second job onwards. Okay, if we consider the first job, so the profit of the first job will be added to our answer. Plus, we have to start from the next index. Next index is the index which is the next first job, which is not overlapping with the IDX job. To figure out the next index, I'm using binary search. Find next job. We have start time of every job, and the last ending index. That our job is ending at this position. It means I have to find a value which is equal to or greater than this value. So for that I'm using binary search. If start time of mid is greater than equal to last index, it means this can be the candidate answer. We will capture that mid value and keep on searching on the left side until we find the last candidate. So ultimately this next index will store the first job which we can pick after calculating the IDX job. Okay, now these are the two main conditions. The maximum of these two values will be our answer for this IDX job that we are memorizing and returning from this. And before processing, we are also checking whether we have previously calculated it or not. I'm initializing with -1 because 0 can be our answer. Okay, so let's now try to submit it. This code I wrote on my IDE IntelliJ. We have job scheduling, converted the job to the job list, sorted the list, and then finded the maximum profit by using dynamic programming. And to search the next index, I'm using binary search. So it is using DP, top-down DP with binary search. Sample test cases are passed, submitting the problem. Now it's submitted successfully. Hope you understood the problem. Thank you guys. And for the code, I'm attaching my GitHub repository link in the description below, where you can find code of this problem as well as all the previous problem that I have already solved. Okay, thank you guys.